Hello everyone. In this problem, there is an object on the ramp. It starts from point P and passing through point Q and reach the highest point R, and it stops and it goes back to the original position P, and there is an interval with friction between Q and R. So the mechanical energy will be decreased when it passes through the interval of friction. And this amount decrease in the amount of mechanical energy is the same as the increase in the kinetic energy when the object moves from R to Q. And when it goes up or down, the same amount of friction, the same magnitude of friction will be applied. So that means when it goes up and down, the same amount of energy will be lost by friction. And the kinetic energy at the position P is E0. So when it starts, and when it comes back, the amount of kinetic energy becomes E1. And that's the same as the kinetic energy when the object goes up at the position of Q. So let's follow the movement of this object with the time frame. So let's say the initial time is t1 and t2, t3, and from t3 it moves to t4 and t5. So let's make a table with this time frame. So times are 1, 2, 3, 4, 5, and the positions PQR and QP, and the kinetic energy the original amount of kinetic energy is E0, and at Q the kinetic energy is E1, and then when it stops, kinetic energy is 0. And for the potential energy, the original potential energy is not given, so let's say that's E2. And then there will be some loss of energy by friction between Q and R, and the total amount of energy, mechanical energy, is the sum of kinetic and potential energy. So at first, this object has the mechanical energy, the sum of E0 and E2. So when the object is at the position Q, at this interval there is no loss of energy, so it still has the same amount of mechanical energy. That means to find the potential energy, we can subtract kinetic energy from mechanical energy. And then between Q and R, there is a loss of the energy, our work by friction. So let's say the amount is W. In such case, the mechanical energy, now we need to subtract this loss of energy. And that's the same as potential energy, because kinetic energy is 0 at the highest point. And when it moves down, another loss of energy is made with the same amount. So now the mechanical energy becomes minus 2W, and because at T2 and T4 the position is the same, that means the potential energy should be the same. So I'm going to use the potential energy at T2 for T4. So to find the kinetic energy, we can subtract potential energy from mechanical energy. That means E0 and E2 cancel. So kinetic energy at T4 is E1 minus 2 times W. And likewise, if we compare T1 and T5, the position is the same height. So that means the potential energy should be the same. So at T5, the object has the potential energy E2, and from T4 to T5, no loss of energy is made, so it still has the same amount of mechanical energy. So if we subtract potential energy from mechanical energy, the amount of kinetic energy at T5 is E0 minus 2 times W. And then these two have the same amount of kinetic energy, so that means these two have the same amount, so we can make the equation. E1 is E0 minus 2W. And then the decrease in the amount of mechanical energy by friction, W, is equal to the increase of the kinetic energy from T3 to T4, this one. So W is equal to E1 minus 2 times W. So this means E1 is equal to 3 times W, and then E0 is equal to 5 times W. So if we change W to E0 over 5, E1 is equal to 3 times E0 divided by 5. So the answer is the second choice. And that's it for this video, and thanks for watching.